Today, we're going to dig into something pretty incredible, a digital revolution that's happening right under our feet. It's all about some amazing technology that's quietly changing the game for farming and really helping us tackle the huge challenge of how we're going to feed our future.
Okay, let's start with a number, 9.8 billion. That's how many people we're expecting to have on this planet by the year 2050. It's a huge number, right? And it brings up a really, really big question. So how in the world are we going to feed everyone? I mean, think about it. The way we've always done things, it's just not going to cut it anymore. We have to get smarter about how we grow our food. And that's the core of the global farming challenge.
For most of history, farming has been a bit of an art and a lot of guesswork. Farmers would use their experience, their gut feeling, to decide when to water or how much fertilizer to use. But they were basically flying blind, without knowing exactly what the soil needed moment to moment. And when you're just guessing, you can end up with a lot of waste, pollution, and honestly just not getting as much food as you could. So how did they try to solve this? I mean, what was the old way of figuring out what was actually in the soil? Well, let's just say the answer was slow, it was expensive, and it definitely didn't happen right there on the farm. Okay, this slide really lays it all out, the old way versus a new. On one hand, you've got lab testing. Think slow, a ton of work, expensive, and you only get a single snapshot in time. It's like taking one photo of a whole movie. But on the other hand, real-time sensing. We're talking instant results right there on site, and it's way more cost-effective. To really get why this is such a huge leap forward, let's break down that old lab process. So yeah, you had to go out, collect samples, dry them, sieve them, do all this complex chemistry, and then you just waited for days, sometimes weeks. Now, this process is super thorough, don't get me wrong, but for a farmer who needs to make decisions today, it's just not practical. By the time you get the results, the field could be completely different. It was pretty clear we needed something way, way faster. And that's where things get really interesting. Because that better way, it's here. We figured out how to give the soil its own voice, a digital voice that can tell the farmer exactly what it needs right when it needs it. And this is it. This is the piece of tech that makes it all happen. It's a soil NPK sensor. Basically, it's a tough little probe that you stick right into the ground, and it measures the three most important nutrients for plants: nitrogen, phosphorus, and potassium. You'll hear that called NPK a lot. So why those three? Well, N, P, and K are pretty much the big three macronutrients. They're the building blocks for healthy plants. Think of it like this. Nitrogen gives you those nice green leafy parts. Phosphorus helps build strong roots and beautiful flowers or fruit. And potassium? That's kind of the all-around manager. It helps the plant handle water and stay healthy enough to fight off diseases. Getting that NPK balance just right is absolutely key. Okay, so how does this simple-looking stick actually measure all that complex chemistry in real time? It's not magic, even though it kind of feels like it. It's really just a combination of some very clever physics and chemistry. Let's look at how it works under the hood. One of the main ways is through something called optical sensing. The sensor basically shoots a little bit of light into the soil and then measures how that light bounces back or gets absorbed. It's pretty cool because different nutrients interact with light in their own unique way. By analyzing those light patterns, the sensor can figure out what's there, all without even disturbing the soil. Another method is electrochemical sensing. Now, this one's a bit more direct. The probe has these special electrodes, and each one is designed to react to a specific nutrient ion, like a key fitting into a lock. So one looks for nitrogen, another for potassium, and so on. This method is super sensitive and incredibly precise. And the third big one is electrical conductivity. This just measures how well the soil can conduct electricity. Now, why would we care about that? Well, it's simple. The more nutrients that are dissolved in the soil's water, the better it conducts electricity. So this gives you a fantastic overall snapshot of how fertile the soil is at that moment. And look, this isn't just some lab experiment. It's a real practical tool. Researchers have found that it's an extremely efficient and effective means of on-site monitoring that directly boosts productivity. So the science is solid, but how does that data actually get from a probe in the dirt to something a farmer can actually use? Well, it all works together as one neat little system. The sensor grabs the raw data from the soil. Then that data gets sent through a communication module to a tiny little computer. That's the brains of the whole operation. This little chip processes all the numbers and then shoots them over to a display so the farmer can see exactly what's going on.
Okay, so let's bring this all back to where we started. Remember that big number, 9.8 billion people? This is where all this tech really becomes a true game changer. This isn't just about cool gadgets, it's about building a sustainable future. So, this is what it actually looks like for a farmer. Instead of just guessing, they get hard numbers. They can look at a screen and see, okay, my nitrogen is below 240 kilograms per hectare. It's too low. I need to add some. Or, whoa, it's over 480. I need to stop adding fertilizer right now to prevent waste. That right there, that's precision agriculture.
And the benefits just stack up. It creates this amazing chain reaction. It's a win for the farmer, right? They get more crops and spend less money. It's a huge win for the environment because we're cutting down on all that fertilizer pollution. And ultimately, that means it's a win for all of us because we get healthier food that's grown more sustainably. When you boil it all down, what we're seeing is a massive shift. We're moving away from farming based on guesswork and instinct and into an era of farming with real, hard data. It's about making smart, data-driven decisions instead of just flying blind. So that leaves us with a pretty big question to think about. If data is becoming the new soil, if it's becoming just as vital as the earth itself, what will the farms of tomorrow even look like? What other incredible changes are just over the horizon? It really makes you wonder. Thanks for diving into this with us.